Looking at your second chapter review on chapter 2, you're going to notice on number 1, it says find f prime of x using definition of the derivative. And remember your definition of your derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So this very first thing that we have to do is we're going to go ahead and substitute and find f of x plus h. Or in other words, x plus h is going to go in place of all of our x's in our equation. So when you do that, you're going to get x plus h squared, and then plus 3 times x plus h. And you still have your plus 4. And then we're going to go ahead and subtract our f of x. So minusing the f of x, so that means you're going to minus this whole entire equation right here. So minusing that whole entire equation, we're going to minus the equation x squared plus 3x plus 4. And then when we're done doing that, we're going to go ahead and divide everything by h. So now we just have to go ahead and simplify this down. And so as we're simplifying it, you notice we've got to take this x plus h, we've got to multiply that together first. So remember that is actually x plus h times x plus h. Or in other words, I have to use FOIL. So first outside, inside, last. So I'm going to have to FOIL this out. So notice my firsts in this equation right here is going to be x times x, which gives us x squared. And outsides is going to be this x and this h right here. And insides is x and h. And when I add x and h together, I'm going to get 2xh. And then on my last right here, I'm going to have h times h, which is going to give me this h squared. Once I'm done doing that, I can go and do this next part right here. And this next part right here, it says that I need to distribute this 3 on through. That's what I'm going to do. I'm going to distribute the 3 on through. And when I distribute this 3 on through, I'm going to get 3x. And when I distribute to the h, I'm going to get 3h. And then I still have my plus 4 right here. Once I'm done doing that, I got to go ahead and distribute this negative on through also. So distributing this negative on through, I'm going to get negative x squared minus 3x and then minus 4. And that's still all over h. Now this next part I'm going to discover is that every term that doesn't have an h in it is going to cancel out. So as I look at this first part right here, I look at x squared. X squared does not have an h variable in its term. So notice it's going to cancel with this x squared, and it's going to go away. 2xh does have an h in its variable, an h in its term. So notice I just write it down right here. H squared, well, that's an h term, so I write it down. Notice this next one, 3x, doesn't have an h variable in its term. So notice it's going to cancel right here. So those are going to cancel out. 3h does not cancel. There's an h in its term. And this last one, I got 4 and negative 4, and those are going to cancel out. And so when I'm done doing that process right there, you're going to notice that I'm left with the following equation. And the following equation that I have is 2xh plus h squared plus 3h all over h. And now I can go ahead and divide every single term by h. So you'll notice I'm going to divide this first term right here by h. And when I do that, I'm going to be left with 2x. I'm going to go ahead and divide this next term by h. And when I do that, I'm going to be left with just plus h. And when I divide this term right here by h, it's just going to be plus 3. When I divide my denominator by h, and of course that becomes all over 1. Of course, we never write that all over 1 because we know that anything divided by 1 is just itself. Now that I've gone ahead and simplified all this, now I'm just ready to go ahead and do this last part, which says I've got to find the limit as h approaches 0 of 2x plus h plus 3. So I'm going to go ahead and substitute in 0 in place of h. So when I do that, I'm going to be left with the answer of 2x plus 3. On problem number 2, the directions on problem number 2 just says differentiate the following equation. Well, to differentiate this equation, I've got y equals x all over x squared plus 1. I'm going to have to go ahead and use what's called the quotient rule. You use the quotient rule whenever you have an equation divided by an equation, which is exactly what I have. I have an equation divided by an equation. So to kind of remind you of the quotient rule says the following. So as I look over here, I got f of x all over g of x, two separate equations. I'm going to take the derivative of the numerator, so that's f prime of x. I'm going to leave the denominator the same. And then I've got minus, and now I leave the numerator the same, which is f of x, times the derivative of the denominator, which is g prime of x. And then that is going to be all over g of x squared. So you'll need to know the quotient rule for when you're taking your test. And you'll have to be able to apply that quotient rule to a problem on your test. So notice right here, I'm going to go ahead and find the derivative of the numerator. So the derivative of x is just going to be 1. I leave the denominator the same. So that's going to be x squared plus 1. Now I've got minus. Now I'm going to go ahead and leave the numerator the same. So here's my x. Goes right there. And I'm going to take the derivative of the denominator. So here's my denominator right here. The denominator of x squared plus 1 is going to be 2x. And then it's going to be all over the denominator squared. So my denominator right here is x squared plus 1. And put it down here as x squared plus 1 squared. So that's your calculus part of it. Now we've got to go ahead and simplify down as far as we can algebraically. So simplifying this down algebraically, you're going to notice that I got to distribute this 1 on through. And when I do that, I'm going to be left with x squared plus 1. Because on your test, it might be a number more than 1. It might be like a 2 or a 3, so just don't forget to distribute that on through. Now I'm going to go ahead and take this right here. I've got x times 2x, and that's going to be 2x squared. And notice I still have my minus sign right here. And then I still have my x squared plus 1 all squared. Now my last step, just going ahead and putting these two terms together. So notice I've got a common term right here. My common term is x squared and negative 2x squared. I go ahead and combine x squared and negative 2x squared, and that's going to give me a negative x squared. I still have my plus 1, and then that's still all over x squared plus 1 squared. So that's going to be my answer when I do the quotient rule on this problem. My answer is just going to be negative x squared plus 1 all over x squared plus 1 squared. Okay, now on this next problem right here, on number 3, the directions says find dy and dx in the following equation. So remember, when I'm finding dy dx, that just means again that I'm going ahead and finding its derivative. That's what dy dx means. I notice in my problem right here, I've got an equation times an equation. And since I've got an equation times an equation, I've got to use the product rule. And here's what the product rule says. The product rule says I've got an equation times an equation. I take the derivative of the first equation, leave the second equation the same, then a plus sign. I leave the first equation the same, and take the derivative of the second equation. I notice that second equation happens to be a composite function, or in other words, I've got an equation inside of an equation. So then I have to, when I'm doing the derivative of the second equation, I'm going to have to go ahead and use the chain rule. And the chain rule just says you're going to take the derivative of the outer times the derivative of the inner. So this stands for derivative. I'll just write ddx for derivative of outer. And this stands for inner. And I'll just write ddx of inner. And that is outer equation and inner equation. So that's my chain rule. I'm just taking the derivative of the outer times the derivative of the inner. Okay, now that I've done that, kind of explained it, we're going to go ahead and apply the chain rule, or sorry, the product rule. And when I take the derivative of that second equation, I'm going to have to use the chain rule. But before I do that, I'm just going to go ahead and rewrite this so that it's a little bit easier to see my two separate equations. So remember, this is x, and then this is going to be x plus 1 all to the 1/2. Okay, so now let's go ahead and apply the product rule to it. The product rule says take the derivative of this first term, which is x, and the derivative of x is going to be 1. Now I'm going to leave the second one the same. And in this case right here, I just leave that as a root, so that's the square root of x plus 1. Now, it says go ahead and leave the first equation the same. So here's my x, so there's my x right here. Now I'm going to take the derivative of this equation right here. So remember, here's your outer. So remember that 1/2 goes out front, so that's 1/2 times x plus 1 to the negative 1. So there's the derivative of the outer equation. And now I'm going to take the derivative of the inner equation, and the derivative of the x plus 1 is just going to be times 1. Okay, now that I've done that, I'm going to go ahead and simplify it algebraically. So now to simplify this algebraically, I notice that this right here, this is x plus 1 to the negative 1/2, and so that's going to go into my denominator. And notice that this is 1 times x, my numerator. So here's my numerator right here, x. This x plus 1 to the negative 1/2 goes to the denominator, and this 2 is already in the denominator. So that's what it looks like when you simplify it down. Okay, now that you've done that and rewritten it, now we got to go ahead and combine our two fractions together. So remember, when I combine these two fractions together, this fraction is actually the square root of x plus 1 all over 1. This fraction is x all over 2 square root of x plus 1. So that means my common denominator is going to be this part of that second equation, which is 2 times the square root of x plus 1. So that means that over here on this fraction, I have to multiply by 2 square root of x plus 1, both numerator and denominator. So I'm going to multiply it times my numerator, I'm going to multiply it times my denominator. So when I take 2 times the square root of x plus 1, well, 2 times 1 is just going to be 2. But then notice the square root of x plus 1 times the square root of x plus 1 is going to be x plus 1. And when I take this denominator and multiply it together, and I have 2 square root of x plus 1 times 1, that's just going to be 2 square root of x plus 1. And now notice that these two fractions have the common denominator. So on the one, I've got 2 times the parentheses x plus 1 all over 2 square root of x plus 1 plus x all over 2 square root of x plus 1. And so now I'm going to go ahead and be able to combine those together. To be able to combine them together first, I'm just going to go ahead and take the 2 right here and distribute it on through. So this is going to give me 2x plus 2, and now I still have over my denominator, and then I still have my other fraction over here. So the laws of fractions say once you have a common denominator, you can add or subtract your numerator, keep the same denominator. And that's what I'm going to do right here. I'm just going to go ahead and add my numerator together. So notice I got 2x plus x, that's going to give me 3x. And 2 doesn't combine with anything, so I just write it down. And then that's all of the common denominator of 2 square root of x plus 1. So when you look at this problem right here, that's your final answer, which is 3x plus 2 over 2 square root of x plus 1. Now number 4, the directions say find f prime of x for the following equation. And remember, f prime of x is just mean find its derivative. So to find its derivative, I've noticed that in this case right here, I've got an outer equation, and I've got an inner equation. So that means I'm going to have to use the chain rule. The chain rule says the following. Take the derivative of the outer, so that's what this right here means. It means take the derivative of the outer. So this is your outer equation. And we want to find its derivative. And then we're going to take that times the inner equation. That's what this stands for, the inner equation. And we're going to find its derivative. And so that's symbolized by d dx of the inner equation. So applying the chain rule to problem number 4, we're going to go ahead and do those steps. So I'm first going to go ahead and look at my outer equation, which is 4x minus 1 all to the third. So remember, chain rule says, multiply this down front. So this 3 comes down here. And then remember, you're going to subtract 1 from your exponent. So that's 3 times 4x minus 1 squared. And now this inner equation, which is 4x minus 1, take its derivative, and you're going to get 4. So now all you have to do is just take these two and multiply them together, algebraically. So we take 4, and we're going to multiply by the 3, and 4 times 3 is going to give us this 12 right here. And this part right here, the 4x minus 1 squared, isn't going to change. So factored form is called simplified form. So f prime of x is just 12 times 4x minus 1 all to the second power. Okay, number 5, it says it wants us to find, and then it says d squared y all over dx squared. So remember, that actually means the second derivative. So we're going to find the second derivative of this problem right here. So again, you're going to notice we've got an equation over an equation. So that means we're going to have to use the quotient rule. And the quotient rule says the following. If I have an equation over the equation, I take the derivative of the numerator equation times the denominator equation minus, leave the numerator equation the same, take the derivative of the denominator equation, and that's all over the denominator equation squared. Applying this quotient rule to this problem right here. So notice I'm going to take the derivative of the numerator, so that's going to be 1. Leave the denominator the same, so that's going to be x minus 1. Now I'm going to go ahead and take the numerator and leave it the same. So this x stays the same. And then take the derivative of the denominator, which is going to be 1. And then this is going to be all over the denominator. So there's my denominator right here, squared. And there's your first derivative. Simplify it down a little bit. So to simplify this down, I go and distribute the 1 on through. And when I do that, I'm going to get x minus 1. I take x times 1, which is going to be minus x. And then this is going to be all over, still the denominator squared. Now that you've done that, here's your first derivative, y equals negative 1 over x minus 1 squared. You're going to notice now you don't have to use the quotient rule because you don't have an equation divided by an equation. So what I'm going to do is I'm going to go ahead and use my laws of algebra. I'm going to take this, and I'm going to move it to next to my numerator by changing its power. So notice this is plus right here. So I can move it up here and change that to negative 2. Once I've done that, now I can go ahead and use the chain rule. And the chain rule says take the derivative of the outer equation. So here's my outer equation right here. And my outer equation is negative 1 times x minus 1 to negative 2. So remember, your derivative of your outer, take negative 2 times negative 1. It's going to be a positive 2. And then I'm going to go ahead and subtract 1 from this. And negative 2 minus 1 is going to be negative 3. And then I'm going to go ahead and multiply this by the inner equation. And I didn't bother writing this down, but I'm going to go ahead and write it down just in case there's a number in there. So the derivative of x minus 1 is going to be times 1. Now to finish this off, we just go ahead and take this part right here, that's just x minus 1 to negative 3. I'm going to put it back down into my denominator. And remember, this minus sign changes to a plus sign. And you don't actually see the plus sign because if there's nothing there, it's pretty much just understood. And then this 2 right here is just going to remain in the numerator. And so your second derivative is just going to be 2 all over x minus 1 to the third power.